Hi everyone, this is Kiranmay from H&S department. Today in this session, we are going to discuss about a P-N junction diode. Under this topic, we are going to have formation of P-N junction, energy level diagram for a P-N junction, biasing of P-N junction, and the characteristics of P-N junction. First of all, what is a P-N junction and how it is formed? See, when a layer of P-type semiconductor material is placed on a layer of N-type material in such a way that atoms from the P-type combine with the atoms of N-type across the surface contact. That surface junction where combination has occurred is known as P-N junction. In practice, we can form or obtain a P-N junction by three different ways. One is ground junction method, fused junction method, and diffuser junction method. First of all, ground junction method. In ground junction method, we are supposed to do the complete process during the growing process of the crystal. That means when the crystal is growing, on both sides of the crystal material, donor and acceptor impurities are injected to a single crystal while the crystal is growing itself. Then on both sides of the crystal, on one side N-type material will be formed and on the another side P-type material will be formed so that a junction will be formed between them. Hence, such type of material is called ground junction method. Whereas in alloy junction method or a fused junction method, there two different materials, N-type and P-type, both are taken and they are kept in contact and they are fused together by heat treatment. So that those two junctions will get attached to itself, attached to them itself, and a junction will be formed between them. Such a process is called alloy or fused junction type. In the third process, diffuser junction type, which is a very important one, which is used in today's life, that is diffuser junction method. In this process, either of the substrate has been taken, either a N-type substrate or a P-type substrate has been taken, and it is one is painted with the other material. For suppose if you had taken an N-type substrate, it is painted with P-type material and both are heated, so that atoms will diffuse from one side of the substrate to the another side, so that a junction will be formed between them. Such process is called as diffuser junction method. By any of these three methods, a P-N junction has been formed. Now let us see how the junction will be look like. See, after the formation of P-N junction, holes will move from, as the holes are the majority carriers in P-type material, holes will move from P side to N side and electrons will diffuse from N side to P side, so that at the junction they will combine with each other. This leaves they will combine with each other, and this leaves the N region near positively charged and P region as negatively charged. Why? Because after what happens, the electrons which has been moved from N type, they will be uh, they will be accepted by the atoms which are present in the P-type material, and the holes which are coming from the P-type material, they will be recombined with the electrons. Hence, ionized atoms will be present at the junction. That too, negatively ionized atoms on the P side and positively ionized atoms on the N side will be formed at the junction. Due to this formation of ions at the junction, potential will be developed over there, which is called as barrier potential. Barrier potential. Due to the formation of ions at the junction, a potential will be developed, which is called as barrier potential or junction potential. Coming to the energy level diagram of P-N junction, on P side, the holes are the majority carriers which are present in valency band. Hence, Fermi level will be very nearer to valency band in P-type material. Whereas in N-type, the majority carriers are electrons which are present in conduction band. Hence, Fermi level will be towards the conduction level. Now, when you join this P-type material to a N-type material, the Fermi level will be common for both of them. Fermi level will be common for both of them. Depending upon the Fermi level, the energy level diagram, this is P side and this is N side, where on P side, valency level will be nearby to the Fermi level and conduction level will be far from the Fermi level. And on N side, conduction level will be nearer to the Fermi level and valency level will be far from the Fermi level on N side. So joining the valency level of P type to valency level of N type, conduction level of P type to conduction level of N type, hence forms an energy level diagram for a P-N junction. The difference of fields at this junction will give the barrier field, that is EB is equal to EVP minus EVN and EB is equal to ECP minus EN. This is the barrier field EB. This can be written in other forms like in terms of potential also. See, for suppose the contact potential at the junction will be like potential on N side minus potential on P side. That will give the potential difference across the junction, that is equal to barrier potential. VB is equal to VN minus VP. So the depending upon this potential, barrier potential, you can write barrier field as charge into barrier potential, that is E into Vn minus Vp. So when two electrodes are taken from the p-type and n-type material, that forms a device called as P-N junction diode, and its circuit symbol is as shown in the figure. As shown in the figure. So coming to the biasing of P-N junction. So this biasing of P-N junction can be done in three different forms. One is unbiasing, another one is forward biasing, and then reverse biasing. Unbiasing, actually biasing means giving external energy. Unbiasing means we are not supposed to provide it with any sort of external energy. So when the P-N junction is unbiased, it is in equilibrium and in contact potential appears across the junction, that is nothing but VB. So the potential across the barrier will be equal to barrier potential VB. Therefore, the barrier field is equal to E into VB minus E into VB. Then in forward biasing means P-type is connected to positive terminal of the battery, N-type is connected to negative terminal of the battery. Then such sort of biasing is called as forward biasing, where forward potential moves from P side to N side and barrier potential moves from N side to P side, as both are in opposite direction. Hence the potential across the barrier will be equal to VB minus VF, as VB and VF are in opposite direction. Therefore, since the potential across the junction got reduced, electric field across the junction also reduces. Therefore, width of the region also reduces. Hence, forward biasing across the junction offers less resistance value. The same thing when we see in the energy level diagram, you can observe on the screen that as the uh, potential across the barrier is decreased, field across the barrier also decreased. Hence, the width between the width of the junction also got decreased, so that valency level of P type and conduction level of N type got involved, got down the Fermi level of the material. Then comes the reverse biasing of P-N junction, where positive terminal is connected to negative terminal of P-type is connected to negative terminal of battery, N-type is connected to forward terminal of the battery, so that both barrier potential and reverse potential will flow in same direction. Hence, the potential across the barrier will be summation, that is VB plus VR. Since potential across the junction got increased, barrier field increases, hence barrier width also increases. Therefore, reverse biasing offers high resistance for the flow of current. Hence, when you see that in the form of energy level diagram, see the junction width got increased, so that why the junction width is increased? Because potential and field across the junction got increased. Hence, it offers more resistance. Coming to the VI characteristics of P-N junction, since in unbiased condition, as we are not supposed to give any external energy to the junction, there is no flow of carriers. Hence, there is no current flow through the junction. Whereas in forward bias circuit, as the diode is forward biased, potential barrier height is very small. When the applied voltage exceeds this small value itself, the junction resistance becomes zero. Hence, small increase of applied voltage produces large increase in circuit current. This current is called as forward current. Hence, in forward bias, a very less resistance, about 100 ohms, is offered for especially for a germanium diode. Whereas in reverse bias conditions, a slight reverse current flows in the circuit even for the large increase of bias voltage. Why? Because as you apply the reverse voltage to the junction, all the carriers are attracted towards the terminals but not towards the junction. Hence, hence the carriers which are less in number, minority carriers, they will flow towards the junction. Hence, current constitutes due to minority charge carriers, which is a negligible value. When the applied reverse voltage is high enough to break the covalent bonds, current rises suddenly in the circuit. Such a voltage for which covalent bonds breaks voltage is called as breakdown voltage or reverse voltage. And for a germanium diode, the reverse resistance will be around 1 mega ohm. See on the screen, you can observe the characteristic structure of a P-N junction diode, where in the forward characteristics, up to certain in minimum voltage, the current will be zero in the circuit because of the barrier potential. Once the applied potential is beyond the barrier potential, current slowly starts increasing in the circuit for a increase in applied forward potential. Whereas in the reverse direction, even for the large increase in reverse voltages, current will be very minimum due to minority charge carriers, which is called as reverse leakage current. When the applied reverse potential is large enough to break the covalent bonds, suddenly bonds will break, minority number will increase, there will be a rapid change in current flowing through the circuit, hence breaking down the hence damaging the junction. Therefore, beyond breakdown voltage, a PN junction diode will be damaged. Thank you.